Thank you, good student, for finding this time to be in my class. Today, I want us to go through circle theory. Sometimes we call it the angle properties of a circle. So I'm going to discuss the property one by one so that by the end of the discussion, you should be able to know how one property is related to a particular angle in a circle. The first one I want us to look at is the angle at the center of a circle and the circumference. That is the angle at the center of a circle and the circumference. So always angle at the center of the circle are usually twice that on the circumference. For example, on the first circle, the angle at the center here is twice that of the circumference here. If this angle, for example, is 40, if this angle is 40, then automatically this angle becomes 20. And if this angle is 30, then you expect angle at the center to be 60. Similarly, if we take the reflex angle at the center, this one, this reflex angle is going to be twice the other angle on the circumference here. That is, the angle at the center is twice that on the circumference. That is property number one. Now, property number two, I'm looking again at what we refer to this case as a cyclic. And a cyclic is a four-sided figure in a circle. Now, for a cyclic, opposite angle of a cyclic add up to 180. So angle A plus angle D should give you 180. On the same way, angle B plus angle C should add up to 180. So the sum total angle in a cyclic add up to 360. I take that one as property number two. The third property I'm checking on is the angle in the alternating segments. So if I'm given a tangent, that is A, B, and C is a tangent. Now, the angle that alternate, that is, look at A and this A, those angles are alternating. In other words, they are in alternating segment. So the two angles are equal. Similarly, this angle B is alternating to angle B here. So the two angles are also equal. So for example, if this one is 30, that angle A is 30, then also this angle A is 30 degrees here. So what we usually conclude is that angles in alternating segments are equal, as we have discussed on that one. That one becomes our third property. The other one that I also want us to consider is the angles or the chord and the perpendicular line through the center of the circle. So in most cases, if the perpendicular line through the center of the circle is drawn, it usually bisects the chord. So if we draw a perpendicular line through the center of the circle to the chord, then it will bisect that chord into two. So if this chord, for example, if the chord AB is 6 centimeters, so here we are going to have 3, and here also is going to be 3 centimeters. So the perpendicular bisector of a chord passes through the center of the circle. Number 5, I'm looking at the tangent to the circle, tangents to the circle. Now, if we draw tangents from a point C to the circle like this one, the two tangents to the circle, then the two tangents are going to be equal, and therefore their base angles are also going to be equal because they are going to form an isosceles triangle. So tangents from a point to the circle, then the two tangents are equal. Now, the other property that I want us to consider, number 6, is angles in a semicircle. That is the angle in a semicircle. So if A or C, where O is the center of a circle and SC is the diameter, then angles subtended by the diameter to the circumference, those angles are always right angle. So angle A ABC is 90 degrees, reason being that angle is subtended by the diameter to the circumference. In other words, we can actually state this property that angles in a semicircle are always 90 degrees. The other property that I will consider, number 7, is the radius and the tangent. So in most cases, the radius and the tangent always meets at 90 degrees here. So if I draw a radius to the tangent, they will always form a 90 degrees at the point of intersection. So anytime you find a circle interacting with a circle and you find a radius to the tangent, then a point of intersection, they form a right angle triangle or a right angle of 90 degrees. The other property, number 8, is angles subtended by the chord to the circumference. Now, if I consider chord CD, so they're subtending the angle A to the circumference, this angle A here. Similarly, this chord is also subtending this angle here, angle B here. So in short, what we are meaning at this point is that angle A is equals to angle B. Reason being, they are subtended by the same chord to the circumference. So always angle subtended by the same chord at the circumference in the same segments are always equal. So anytime you find a circle, look at that property to be able to conclude that property in an easy way. The other property that I'll be considering is about the intersecting chords. The chords that intersect internally in a circle, like the one provided here. For example, chord AB and chord CD intersect at point Y. So therefore, these two chords will be related by this, that AY, that is AY, multiplied by YB should be equals to a DY multiplied by YC. For example, if this one is 4 here, and this one is X, and this one is 3, and this one is 4 here, then it means 4 multiplied by X, that is 4 multiplied by X, should be equals to 4 multiplied by 3. And therefore, it will be easier for you to find that value of X if required. So for intersecting chords internally, then remember this, AY multiplied by YB should be equals to DY multiplied by YC. The other property that I'll be looking at is the secant and the tangent intersecting externally. That, for example, I'm being given here a secant, that is the secant PTQ, and the tangent RQ intersecting externally at point Q. Then it means that P multiplied by Q should be equals to TQ. That means P Q multiplied by TQ should be equals to the tangent squared. So at this point, you can relate this, that PQ multiplied by QT should be equals to the tangent square. That is in the case of secant and the tangent. Then lastly, if you're given 2 seconds intersecting externally, look at this one, then also it means that AC multiplied by BC should be equals to DC multiplied by EC, as you can actually see here. That is in case for the secant that intersect externally. So I believe that 11 properties or angle properties of the circle are relevant for you to be able to internalize that concept of the circle theory. So in case you are told to find the angles in a circle, try to look at those 10 or 11 properties and then try to get the angle of a particular angle or a particular given angle using those properties. So I believe that short demonstration was enjoyable, and I believe you have understood on how to get those angles whenever the question is required or requires you to do that. So remember to be part of my class by subscribing to this channel. Thank you for your great time, and I appreciate a lot. Thank you.